So welcome back to another video of electronics. So today we're going to talk about logic gates. So before moving on to the topic and knowing what's logic gates, we need to know what's Boolean numbers. So Boolean numbers are generally referred as 1 and 0. So logic gate deals with these ones and zeros. It's not just 1 0 or 0 1. It might be infinite numbers of ones and zeros. So we need to see how each and every logic gate works. So we'll see each and every gate one by one. So the gates we're going to study about today is NOT gate, AND gate, OR gate, NAND gate, and NOR gate. So without wasting further time, we'll move on to the NOT gate. NOT gate, the logic NOT function output is, if output is true when it's been single function, input is false, and false when it's single input is true. So here true and false refer to 1 and 0 respectively. So if the input is 1, the output is 0. And if the input is 0, the output is 1. So this is how the NOT gate works. So let's say if the input A is 1, the output here is 0 at the end of the NOT gate. You see the truth table of NOT gate. Truth table is basically the input that you give to the gate and the output you get. So this, as I said, if switch, we give the input as 1 and we get the output as 0. And the switch, if we give the input as 0, we get the output as 1. And it is expressed as A dash. So we refer as 1 and complement of 1, which is 0, or 0, or complement of 0, which is 1. AND gate, the logic AND gate function, output is only true and all of its inputs are true. Otherwise, the output is false. So AND gate takes two inputs. If both the inputs are true, that is, both the inputs are 1, we get the output as true, which is 1. If either of or even any one of the output is false, or if any one of the output is 0, we get the output as 0. You see, in the first input, we give both as 0 and we get 0. In the second one, we give 1 0 and 1 to the one input we give as 1, but still we get 0 because for AND gate, the condition is both the inputs should be true. So which is not happening in the second case. And even in the third case, we give one as true and the other as false. That's the reason we get output as false again. But in the last input, we give both inputs as 1, and which leads to the result as or the output as 1. So this is the truth table for AND gate. Let's move on to the next gate, OR gate. The logic OR function output is only true if one or more of its inputs are true. Otherwise, the output is false. We saw that in AND gate, we needed both the outputs to be true to get the output as true. Whereas in OR gate, it's not necessary. If even one of the output is true, we get the output as true. If both the output are false, that's the only result where we get the output as false. Let's say in A and B, if either or even one of the output is true, we get the output as true. Truth table, as you see, just in the first inputs where both inputs are 0, that's the only case we get the output is 0. In the rest of the three cases, we see one or both the inputs are 1. That's the reason we get output in other three cases as true. NAND gate. To simplify NAND gate, let's say it is a combination of NOT and AND gate. So NOT and NAND. So if let's take an example, 0 and 0. We give both inputs as 0. And the output should be 0, but we get the complement of 0, which is 1. So we'll read the definition and move on to the explanation. The logic NAND function is a combination of the two separate logical functions, the AND function and the NOT function. As I said, it's like a combination of NOT and AND. The logic NAND function can be expressed by the Boolean expression of A dot. The logic NAND function output is only false when all of its inputs are true. Otherwise, the output is always true. Instead of taking it in this way, you can take it as I said. Do it the AND way and take the complement of the output. And this is the diagram for NAND gate. let's look at the truth table. So see, as per AND gate, if both the inputs are false, the output also should be false. And if only and only both inputs are true, that's the only case we get output as true. But here, if we give two inputs as false, which should give the result as 0. But because it's an AND gate, we get the complement of 0, which is 1. That's the reason we call it as an AND gate, not AND. Again, 0 and 1, the output should be 0, but the output is the complement of 0, which is 1. And in the final case, 1 and 1, the result should be 1, but we get the output as complement of 1, which is 0. It's the same thing with NOR. The logical NOR function is a combination of two separate logic functions, the NOR function and the OR function, connected together to form one single logic function, which is the same as the OR function, except that the output is inverted. As I said, it works the same way as OR gate, but the result is the complement of the OR gate. Let's say if the way OR works is, if one of the input from either of the two is true, we get the result as true. But in NOR gate, we get the complement of the result, not in NOR. So we'll see the truth table so that we can understand it easily. So 0 and 0, the output should be 0, but we get it as 1, which is the complement of 0. And 0 and 1, since it's an OR gate, NOR, or because even if one of the input is true, we should get the output as true. But since it's NOR and it will give the complement, so we get 0, which is the complement of 1. So we can see that in rest of the two below cases, things repeat. That is, we get the complement of 1. So that's it for this video. Thank you.